All right. So the second type of unconformity is a disconformity. And the disconformity is a gap in the rock record that represents a period of time during which erosion rather than deposition occurred. So it simply represents erosion of sedimentary rock layers. It's kind of a lame unconformity. So in the case of disconformities, the rocks below the missing period of time and above it are sedimentary, and they're all horizontally positioned. An example of this, or of how this could happen, is the following. So imagine that you have sediments getting deposited in a coastal type of environment. But due to climatic conditions, the sea level drops, and you no longer get water as the carrier of sediments. So deposition stops at that site. Later, the sea level rises again, this time higher than it used to be prior to the initial deposition. But prior to any further sediment getting lithified, as more muddy sediment would be, since it is now higher sea level, turbidity currents, which are strong currents that flow down the steep slopes of continental margins, erodes away the new sediment as well as some of the previously sedimented sedimentary rock, that probably more sandy type sedimentary rock that had originally been lithified. So after this, there is a normal deposition of the finer sediment, the more kind of muddy type sediment, that gets lithified on top. And overall, this scenario shows what a disconformity looks like: a period of time during which there was non-deposition or erosion of sedimentary rock layers that were horizontally deposited on the bottom and horizontally deposited on the top. The third type of unconformities are nonconformities. So in nonconformities, there is a gap in the rock record between an older metamorphic or intrusive igneous rock and the younger sedimentary rock that overlies that. So this type of unconformity indicates a period during which there must have been uplift of that igneous intrusion or the metamorphic rocks all the way to the surface. Then there must have been erosion of the overlying sediment on top of these, or rocks on top of these, and probably some erosion of the igneous or metamorphic rocks as well. And then there was the deposition of the overlying horizontal sedimentary rocks. So this image right here shows pretty well what a nonconformity is going to look like. The squiggly lines usually represent metamorphic rocks. The little kind of hashed patterns tend to be igneous rocks. Nonconformities can also occur, like if, for example, I have this igneous body right here, but I have sedimentary rocks around it. The specific boundary between the igneous rock and the overlying sedimentary rock is a nonconformity. However, if you were to look at the boundary between this sedimentary rock and this, which we're calling sedimentary rock as well, it would be a disconformity. So unconformities can grade from one side or one place to another, depending on what kind of rock you have and what kind of conditions you have. So this is what has been seen in these two different pictures that we have here. The topmost picture is a picture of the Precambrian granite, about 1.4 billion years. Yeah, that's right. 1.4 billion years old, which is overlain by this Cambrian sandstone, only about 500 million years old. So there is a period of missing time of close to 1 billion years in between the two rock layers that are right next to each other. In the picture on the bottom, I think this is the Vishnu schist in the Grand Canyon. So this Vishnu schist is almost 2 billion years old, and you see that the overlying sedimentary rocks are of Cambrian age, which is about 500 million years old or so. So there is a period greater than 1 billion years, completely missing from the rock record in between the two. So overall, this is a good example that we have. These are all the rocks that are exposed in the Grand Canyon of the Colorado River, which represent the tremendous span of geologic time. The canyon itself shows this colorful strata that record a very long history of sedimentation in a variety of environments. Environments such as rivers and deltas, such as tidal flats, such as the regression or transgression of seas, and environments like sand dunes as well. So we see a very long history of different types of environments all happening in the same pretty much geographic location, or at least a plate type of location. But like most places, the record itself is not continuous. Much of the time that is not recorded by the canyon rocks is represented by the different nonconformities that are recognized within that rock sequence. So you can see in the slide that in the record that has been studied by geologists, how they have been able to recognize all three types of nonconformities within that rock section. So we see a nonconformity down here between the Vishnu schist and the Zoroaster granite, and this top Tanta group, which is for the most part shale and sandstones. You also see an angular unconformity, which is not lying quite at this section, but further down, or further away from there, which is from this Onkar group, which is a bunch of limestone and shales, if I'm not incorrect. And then you see two different disconformities right here. One between the Moab limestone and the Redwall limestone, and then one in between the Redwall limestone and the Supai group, which is, I think, also a bunch of shales for the most part and kind of mudstones. Okay, so in the next few slides, I'm going to show you a reconstruction of events of the cross-section above, so this guy, on a hypothetical scenario. So you will basically have to do this for your activity on this chapter, so it may help you to go ahead and pay attention to this reconstruction of events. So the first thing that happened in order to get this layer down here is that there was deposition of this layer, of the stratum number 1. And here you see the principle of original horizontality exemplified. So this deposition of the sedimentary rock layer has been deposited horizontally. I should also clarify that in geology, the number 1 means older, and as it increases, it gets higher number. As it gets younger, the numbers increase. So the next thing that happens was further deposition of two other strata on top of the first one. So here the principle of superposition is represented, where again the older layers are overlain by younger layers. So older layer being 1 is overlain by these two younger layers. Okay, next thing that happened is that there was erosion of part of the last stratum that was deposited, and later further deposition happened on top of that last stratum that was eroded. So by the past erosion of the horizontally laying sedimentary rock and the subsequent deposition of the horizontally laying sedimentary rock, a disconformity is represented in between the two sedimentary rock layers. So again, this is going to be a period representing non-deposition or erosion, in this case erosion, of horizontally deposited sedimentary rocks. So here we can see that an intrusive igneous body made its way upward, cutting through the previously deposited strata. Hence, we see that the principle of cross-cutting relations is exemplified. So, the intrusive body cutting through all of the other layers is younger than the other layers because it is cutting through them. So after this, another period of erosion occurred. This time it cut through the intrusive body as well as some of the sedimentary rock layer that the intrusive body cut through. here, further deposition happened, and combining this further deposition of a horizontally laid sedimentary layer with the previous erosion of the intrusive igneous body, this makes a nonconformity in between them. So right here, there's a nonconformity. Again, erosion of the igneous rock with subsequent deposition of the overlying sedimentary rock. Okay, so here, all of the strata that has thus far been deposited and changed are faulted by a normal fault. So again, we'll cover fault in chapter 9. But you see that one block has displaced, it has moved downwards, and then one of them has moved upwards. And represented by the principle of cross-cutting relationships, the fault has got to be younger than all of the strata that it cut through. So later you have subsequent deposition, and as you can see, the layer 7 is not cut by the fault, which means that it has to be younger than the fault because it's not cutting, or it's not being cut by it. Alright, so here you have deposition, and you see that pieces of the layer 7 are incorporated within the next stratum, stratum number 8. So this represents the principle of inclusions, where the inclusions, or the fragments that are contained in another rock mass, that being 8, must be older than the rock mass that they are contained in. So again, pieces of 7, which we know is older than 8, are contained within 8, which means 8 is younger than the pieces it contains. Okay, and here you have deposition of the next 3 strata, again exemplifying principle of superposition. And in here you have a river that probably carved through those 3 horizontally deposited sedimentary layers. And so with that, you can see the principle of lateral continuity also being represented. So you have a river that carved through, but yet we know that this rock layer, if we were to continue it laterally, would be connected with this rock layer, which, as we know, was the case. Okay, and here you have all of the layers in the cross-section tilted by the deformation and subsequent, after you have this deformation, you have subsequent erosion of a large amount of all of these layers. So you see that the last layer, which I think was number 11, has also been eroded greatly. Okay, so finally here, you have deposition of the last sedimentary layer number 12, and thus you have a representation of an angular unconformity. So here you have tilted sedimentary layers that were eroded, so tilted sedimentary layers that were eroded and were overlain by a horizontally deposited sedimentary layer on top. Cool. So overall, you have at point A, right here, a disconformity between layers 3 and 4. You have at point B right here a nonconformity between layers 5 and 6. You have faulting that occurred at C between layers 6 and 7. You have tilting that occurred after layer 11. And then you have an angular unconformity at point D between layers 11 and 12. So this sequence of events is a useful reconstruction of the different events that occurred to this hypothetical scenario. And it gives us an idea of the possible complexity of a section of rocks in any specific locality, and all of the changes that these rocks may have seen or may have been subject to.